Hello everyone. In this video we shall see system generator block, the primary block used when you are implementing a model using system generator. So I hope you are equipped with MATLAB and Vivado. So to open the system generator, you go to start and go to Xilinx design tools at the last. So you click on that and you will see the system generator. Mine is 2018.2 version. You will see the system generator application. You need to open MATLAB from this application. Then only you will find the system generator blocks in the Simulink. Else if you open MATLAB from this application, you can't find the system generator blocks in the Simulink because the system generator application loads the required Xilinx system generator blocks from that path into the MATLAB. But when you load MATLAB from this application, you could only find the blocks corresponding to installation in MATLAB and Simulink, image processing blocks, DSP and some other. You will only find those corresponding to MATLAB but not the system generator. And when you open MATLAB from the system generator application, you will find the lines like this. Type Excel-doc to open the Xilinx system generator documentation. If you click on this Excel-doc, you will see this is the documentation of the entire Xilinx system generator from the introduction to all the block set. You will find each and every block here. Each and every parameter of the block is explained there. You will find all the contents, the explanation of each and every block. You will find in this documentation. Now if you click on the demo block set Xilinx, you will see the system generator examples. This one from the 16QM demodulator from the digital communications. And if you click on this, a model will be appear for this project. And these are some inbuilt projects with the system generator. And this for the image processing, the filters and the color space converter, image reconstruction, and using the math blocks. These are coordinate based rectangular to polar coordinate converter. And you can see the fast Fourier transform in system generator. These are all the inbuilt models. When you are good with the fundamentals, you can try these examples. These are much higher and advanced concepts. So I hope after this course you will start implementing models of this advanced type. So let's get started with our system generator block. So you click on Simulink and create a blank model. So I created a blank model. And this is the Simulink library browser. You find all the Simulink blocks here. Simulink audio system, communication, DSP, and so on. And at the bottom, you will see the Xilinx block set and the Xilinx reference block set. So in Xilinx block set, you have all these elements. The basic elements, communication, control logic, the DSP blocks, memory, and tools, and math. Just we have discussed the quadratic multiplier. These reference block set blocks gives additional support to our basic Xilinx block set. And if you consider DSP, you have the 2N-tap MAC FIR filter. These are inbuilt FIR filters. You can add this filter block directly to your model and implement an advanced filter. And you have the interpolation filter and so on. We shall discuss each and every block in brief in the upcoming videos. I will just explain all the commonly used blocks in our project in the upcoming videos. In this video, I shall explain the basic block and the fundamental block, the system generator. This system generator block primarily implies that you are implementing a model using system generator and it must be dumped into an FPGA platform. So this is the top of all the blocks. Without this block, you cannot add these blocks and run the model. So this is the primary one. So let's look about this. I am adding to this model. So if you double click on this, you will see all the parameters regarding the system generator block. So this is the system generator. There are 3 tabs here: compilation, clocking, and general. We shall discuss each and every one. I will give an overview what is what. So first, the board. If you click on the arrow, you will see a list of boards: Kintex, Ultra 96, RTX, Kintex, Vertex, Jink, and so on. At the time of installation, you have seen these boards. So I have installed some of the boards. So you will see all the boards that are installed in the Vivado. So these are the virtual boards. And the part here, you could see a list of all the parts. These are not the entire complete board, but a part of the board you can simulate here. The Spartan 7, XE775. So these are the boards and the parts related to that. But in our case, we are not dumping the model into the FPGA. We are just simulating in the Simulink and implementing some new models. If you keep the board as none, a part is by default selected. So the Kintex 7, this one is by default selected in my case. If you keep a board, for example, Ultra 96 Evaluation Platform REV revision, if you keep that board, the part will be automatically selected and you cannot change this. You can modify this parameter. So this is all about the board and the part. But if you want to compile this on a board, when you have a physical kit with you, you connect the board to the PC and you will see the hardware co-simulation, and then you can implement the model on the FPGA. And also this compilation tab primarily gives the result of the entire compilation. So the result may be the IP catalog or some synthesized checkpoint or the HDL netlist. So these 3 comes under the simulation within the Simulink, and the hardware co-simulation nothing but you are implementing the model on a physical kit. So if you keep IP catalog, at the end of the process, IP catalog will be generated, and if you keep the compilation tab as HDL netlist, the HDL netlist will be generated at the end. So this is the hardware description language. You can choose between VHDL and Verilog. And if you keep the description language at VHDL, the VHDL library will be loaded automatically. and this is the target directory to load the compilation results. You can choose any directory in your PC. And the synthesis strategy, this indicates how to synthesize the model. You can see some of the options here: optimized area and the performance optimized, runtime optimized, and this is the default Vivado synthesis defaults. So I keep the synthesis defaults as of now. And the implementation strategy, this is the synthesis of the model and this is the implementation of the model. So after the synthesis, the model will be implemented. So you have some options here: performance, explore and condition spread logic, and the area. So these are some of the options. And the create interface document and create test bench, these are some additional options will be provided. So we have the generate here. So when you click on generate, the code for the entire model will be generated. The result will be the HDL netlist or the IP catalog, and the VHDL code will be generated and is stored in the target directory. I will consider an example and explain the code generation. So moving to clocking tab, this is the FPGA clock period given in nanoseconds. So 10 nanoseconds is default, which implies the 100 megahertz. So this is the clock pin location. When you are using a physical kit, you have a clock pin over there. When you want to override to some particular pin at there, you can fill this parameter to the pin location. And this is the Xilinx system period in seconds. So this the sample period, which is equal to 1 by sampling frequency. So if you're considering the model with 100 hertz sample frequency, so you need to keep the parameter as 1 by 100. So this indicates the system period or the sample period. The performance analysis, this tab has two options: post synthesis and post implementation, or none. When you want to perform an analysis which is after the synthesis or after the implementation, you select one of these two and you keep the analyzer type timing or resource. The timing analyzer checks all the timing, that is the slack, delay, rise time and fall times, hold time, setup time, and so on. This timing analyzer checks all those timing analysis in the model for each and every path defined, and the resource analysis estimates the resources consumed to implement the model on the FPGA. So you select any analyzer type and click on launch. So you implement a model and you can select any of the analysis and you click on launch. The analyzer launches and you will see a window with the analyzer and the general tab. This in general the block icon display default, and you can keep any other block icon. So this is all about the system generator tabs. These are the parameters. So we have discussed this. So in the next video we shall proceed with some of the most commonly used blocks: constants, the gateway blocks, and the sign blocks, and the arithmetical logical operations. So in the upcoming videos we shall see those and then implement some of the models using these blocks. Thanks for watching. We'll meet in the next video.